Okay, just to recap what we did in class. Our function x is x squared minus x. So we start by taking, if I want to do f of x, I say f of x equals x squared minus x. That deals with my first function because we're working from the inside out. So right now, I've dealt with this function. Now, I have to deal with this function. We're still talking about function f. So this x gets replaced by everything over here. So the f of x squared minus x. What that tells me to do is replace each of these x's with what's inside parentheses. So I take x squared minus x squared, and then I have the minus, and then I have another x squared minus x. And I think where some people might get lost is with the second one. But if there's more than one x up here, then we're going to replace that x with what's inside parentheses every time. So when we square something, we write it twice. So I'm going to steal this x squared minus x. But that too really means to write it twice. Now, still dangling over there is the minus x squared minus x. Now, as I start the distribution process, x squared times x squared gives us x to the fourth power. Then we've got x squared times negative x, which is minus x to the third power. But then that x squared did his job. He's done. So now it becomes negative x's turn. And negative x times x squared is another x to the third. So this becomes a 2. And finally, a negative x times a negative x becomes a positive x squared. And so now the squaring is done. All we have to do is distribute this negative. So negative times x squared is negative x squared. And lastly, a negative times a negative x is a positive x. So we use our notation, the f of x in this case, right? Equals and here we're just going to combine like terms. We've got our x to the fourth. Nothing to combine with that. But negative 2x to the third is alone as well. So minus 2x to the third, there's nothing to combine with that. But then we have a positive x squared and a negative x squared. They actually cancel, and we just end up with a plus x. And that's our final answer for question 3.